Okay, so this is my attempt to help you learn how to use Google Sheets, or any spreadsheet for that matter, to do some things that are involved in this first part of the chapter 10. And actually, we can use it for the second part of chapter 10 also. But since we're focused on this week, this is what we're going to do. Now, these are the objectives, and we can hopefully help you be able to do with this video is how to make a scatter plot in Google Sheets or spreadsheets. Pretty easy. So this is the first table out of chapter 10, 10.1, and you have this data set available in the form of link to the spreadsheet. You'll just have to go File, make a copy, and then you'll get your own copy of the 10. So now I removed the percent signs. There were percent signs here, and I didn't know if that was messing things up. So this is the table of the percent of alcohol that's in a beer and how many calories in 12 ounces of that same beer. And I believe the exercise wants us, or the example is having us investigate, can we predict the number of calories in a 12-ounce bottle of beer based on its alcohol content. Okay, so we got two quantitative variables, which is important to note. Now, so we're going to do a scatter plot. So I'm going to highlight the data. Notice I included the text for labels. So I'm going to insert a chart. And sometimes it picks up that I want a scatter plot. It didn't this time. It's trying to give me a bar graph. So I'm going to select the scatter plot. If you don't see that, you got to come over here to the chart types. And if you scroll down, then you'll see scatter, and just select it that way. Now we're going to customize this a little bit because it's the lettuce, and we're not going to change the title. And notice that I already filled in the correct X and Y axes. Now it's important to remember in Google Docs, or pretty much in Google Docs, you can specify more in Excel, but you want to make sure your explanatory variable, your X variables are first, your response variables are second, and that'll automatically put it on the X and the Y axis. Okay. So what am I going to do? I'm going to scroll down, and I'm going to have it, I want to have it draw a line on this graph. So while I'm here, why don't I do that for you? Scroll almost all the way to the bottom and see where it says trend line. I'm thinking I'm going to try a linear trend line, and there's some other things you can do. Oh, you know the other thing I'm going to do? I'm going to get rid of the legend. That's none, no legend. Okay, and then I'm just going to insert this into the sheet. I could certainly move this to another sheet if I wanted to, get a bigger view. So what am I seeing here? I'm seeing a more or less linear relationship. So the words I'm going to use is there's a linear association. Notice I didn't use the word correlation. So there's a linear association between calories and the alcohol content. To me, because it looks linear, I can talk about the direction, and I'm seeing a positive direction. As the alcohol content increases, so do the number of calories. And it's not a perfect relationship. If it was perfect, it would be right along that line, and it's not, so we get some variation. So that's the first part. So now we're going to calculate a regression equation, which is this equation right here. Now, before I go there, I'm going to show you, I'm going to, let's see, let me just highlight this. And Rossman Chance has a very interesting applet that I'm going to use. And I'm going to paste in that data, and hopefully it's all right. Use the data there. Let me uncheck some stuff. Okay, so notice it looks a little different, but that's just because the scale's a little weird, okay? So notice they were looking for the explanatory response here. So I put the X, the percentages on the first, the calories in second. And let's see, what am I going to do? I'm going to show a movable line. So what I'm trying to do here is I'm trying to fit a line to this data. Now in elementary school in 7th and 8th grade, your teachers had you graph a scatter plot. Most likely they did. And then you drew what you thought was the line of best fit, we used to call it. And that's looking pretty good. I mean, I think that's following that. Is it the right line? Is it the best line? Well, this applet shows me, hey, show me the regression line. And I see I'm a little off from what they say it is. So what makes that red line, that line that they say is the regression line, any better than my movable line, my line that I've eyeballed? Well, there's this thing called, the fancy name for these regression equations that statisticians use, they're called the least squares regression equation. And the reason they're called the least squares regression equation is this. Okay, let me uncheck some stuff. I'm just going to show the regression equation, the right one. Now, a residual is this distance. Well, how you calculate it, it's the actual value minus the predicted value. So let me see if I can't write that here. So it's a residual is the actual value minus what the line's predicting it should be. Predicted value. And if your actual value is bigger than your predicted value, well, then you have a positive residual. If your actual value is less than the predicted value, you have a negative residual. So what these little arrow lines are, those are the residuals. It's the actual, see that y value? Yes, I should be saying y. So you're subtracting the y's. Okay, so the y value from that point minus what the line predicts is the y value, and I subtract those, and that gives me a positive residual because the actual minus the predicted is positive, is still positive. Now here's where the actual data point is. Here's the actual y value, whatever that number is, and we could probably figure that out right from this table, but we won't go there. Minus the predicted value, and actual minus predicted would be a negative number, and that's why that residual line is down below, and so on and so forth. They aren't too bad. I mean, that's a big residual. Not so bad, not so bad. Okay, now that in itself isn't so special. This, I'm going to have it show me squared residuals. Now you see the sum of squared errors is what they call it, the sum of squared residuals. If you take those residuals and square them, you're going to get a positive number. And if you add up all those areas of those squares, they add up to 2080. What does it do for the movable line that I drew? I'm going to show squared residuals. And notice that number here. What is happening here? This number is supposed to be this one because the regression equation is supposed to be the least squares regression equation. I don't know what's up with this applet. Interesting. Well, actually, no, my residual, I see. I was trying to fit it, it moved it on me. Here we go. Here we go. Did you catch that here? Let me undo this. Okay, certainly threw me for a loop. It had moved, it had undone my original line here. Let me uncheck some stuff here so we can see the stuff. Okay. When it showed me the movable line, it gave me this horizontal line. Now, you probably saw, and I commented how that had a smaller sum of square residuals than the actual least squares line. But this line's pretty worthless for prediction purposes because the y values are always the same. So I'm going to try to fit that line something what I had before. So I think that's pretty close. Now, if I have it show my sum of squared residuals, I'm getting a 2153. Now if I have it do the regression equation, the appropriate line, the least squares regression equation, notice how the sums of squares is less than that. So covered my butt here. I was worried about that for a minute. Yeah, so either line is pretty close, and this is just the line we use as statisticians. Now, what you're seeing here in this is the just a y equals mx plus b form of a line, where m is the slope and b is the y-intercept, and they just wrote it. Statisticians like to write the y-intercept first. Why, I don't know. They just do, and it's perfectly acceptable to write it the other way. But so what we're doing is, here's my y-intercept, there's my slope, and let me uncheck my movable line because that shouldn't be there anymore. So there's my least squares regression equation. If you want to just use this applet to calculate your lines, it's perfectly fine. Remember, my open math might want you to go a few more decimal places, so I will show you how to do that on Google Sheets. Okay, so least squares regression equation. We know what a residual is, right? A residual is those errors from what the predicted line and the actual values are. Let's see, there's our slope, there's our y-intercept. So maybe we should talk about what this means. This slope is, remember, slope from algebra, slope is always a unit rate, how much it goes up for every 1 over, or I mean, if we did other kinds of slopes, you know, there was variations on that, but basically you can always make it so it's over 1, and that's what this slope is over 1. So this tells me that for every additional % increase in alcohol content, the number of calories increases on average by almost 22 calories. Okay, so that's what the slope means in context. And this tells me if the alcohol content is 0, the calories will be 50.52. Not perfect. I mean, if you think about Old Duels, it's been a while since I've drank an Old Duels, so I don't quite remember what the number of calories are, but they are coming in right around just under 100 calories. So, you know, it's not that far. It's not that far off, and probably that's a pretty reasonable estimate. You know, not exact, but it does have meaning. Zero alcohol means is 50.52 calories. So that's actually a good example. Okay, let's go back to the spreadsheet and figure out how to calculate a regression equation by hand. Well, not by hand. We're going to use the sheet for it, and then we'll also get to calculate the residual, make the residual plot, calculate the residuals, make a residual plot. So what are we going to do? Well, remember how this is the X and this is the Y. When you have a spreadsheet calculate a regression equation, this is, I'm going to find the slope of the regression equation first, and I'm going to do equals, and then when I'm going to write the word slope, and you should see it pop up. Actually, let me have it pop up. I'm going to click on it. Then what it's looking for, it's asking for the Y values first. Does it show me that? If I do, let me make sure I go back and whoops. Let me come back here. Equals slope. What does it tell me in the hints? Let's say that doesn't tell me. So what you got to be careful of is when you're calculating using this built-in formula to calculate a regression equation, the Y variables always have to come first. Your explanatory variables have to come first. So all I did was I clicked on that first cell and I dragged down to select them. Now I'm going to put a comma because that's my Y variables. And then I'm going to do the same thing for the X variables. Click on that first cell, drag down to select them all. Notice I didn't let go and I didn't fill down. And there's the slope, and I don't remember, was that still there? 21.91, 21.91, pretty darn good. Now I'm going to have it calculate the y-intercept. And the way you do that with a spreadsheet is do equals, and then write the word intercept. There it is. And then do the y's first, comma, the x's. Okay, so there's my y-intercept. Now what I want you to get in the habit of doing is this. I want you to write, I don't have a way to share that. Oh, what can I do? Just a minute here. There's all kinds of websites, aren't there? Actually, let me go back and create a new board. What I want you to get in the habit of doing, instead of using X's and Y's in your equation, I want you to do this. Actually, let me get rid of my spotlight. I don't need that anymore. Well, I guess it's going to make me do it. We're trying to predict the number of calories, right? So statistically, what we do is we put a little hat over the variable. So that's to denote a predicted value. So I want to predict the number of calories. And the way I do that is I take my 21.91, I think it was my slope, times the percent of alcohol. What is it, COOH? Is that the chemical name for alcohol? Plus what was it, 50 point, oh, I don't remember now. Let's go back. 21.9 plus 50.52. 50.52. So that's a nice regression equation. It tells the person what's your explanatory variable, what's your response variable, and you don't have to worry about X and Y. So I'd like you to do that. I'm going to give you a little quiz, and of course you can't answer. Why did I put that hat over that? Because that's showing it's a predicted value. We're trying to predict the number of calories from the percent alcohol. Okay, so that's our regression equation. I guess the only other thing we should do is I should show you how to calculate. Oh, we should make a prediction. Okay, so, oh, I don't know. How about we do a little Googling here? And it's been a long time to add any beer, so let's see. Magic Hat. I'm going to search for Magic Hat number 9. If you're not of legal drinking age, ignore this. Let's see. Let's see if they'll tell us what the percent is. Oh, they got to tell me how old, ask me how old I am. Well, let's see. A lot older than that. Let's see. They tell me the information. There we go. 5.1% alcohol. So now let's go back to my regression equation. Well, look at that. There's a 5.1. So if I wanted to calculate the number of calories in a beer that's 5.1% alcohol, I'm going to take 21.91 times 5.1 plus 50.52. And I got to remember to follow order of operations, multiply those two, add that. So let's see, what does my calculator tell me? The calculator tells me it's 21.91 times 5.1 plus 50.52. That's telling me, the regression equation is telling me that there's going to be about 161.8, if I round, calories in that kind of beer. Okay. So that's how you use your regression equation and predict. Just out of curiosity, this beer, this Genesee Cream, ale, 162 it says. So there's some error there, and I guess I could maybe find it on my scatter plot, but so let's calculate the residual for that beer. So what is it? It's 162. So the residual, remember, is the actual, which is 162 calories, minus what I predicted. So I'm seeing a residual of 0.2. And it's positive, so that means it'll be above the line. Okay, and we could do that for every beer if we wanted to, and that's how that Rossman Chance applet generated all those lines. Is it took the actual minus the predicted, and then it graphed those actual residuals there. But that's not the residual plot. So what I'm going to do here is I'm going to show you how to do this by hand. Well, it's not really by hand, so I'm going to let the spreadsheet do it. So what I'm going to do is I'm going to have the spreadsheet calculate what the predicted value is for each of these alcohol contents. And that would basically be that line that we graphed. Okay, we graphed X and Y. So here's my slope, here's my y-intercept. So what I'm going to do is equals, and then I'm going to type in 21.91. And yes, there's all kinds of ways that you can lock in a cell, but I won't go into that here. Times, and that I'm just using Shift 8. I'm going to click on that cell, because that's what I want to multiply by the slope. And I'm going to add 50.52. Well, 52. Okay, and that's the predicted. And then I'm going to fill down. So what I want you to see is, see when I put the cursor on that little square right there? You see how it goes to a plus sign? If you click and drag that down, it's going to fill down. And see what it did is it took this next cell, times it by the slope, added the y-intercept. So I don't have to type that in 10 times. Okay. So now let's calculate those residuals. Nice if I could spell too. So the way you calculate a residual is you do the actual value, which was that number of calories, minus the predicted number of calories. And that came up to be that for residual. And then I'm going to fill down. I'm going to grab that plus sign, drag down and fill down. Okay, and there we can see that big residual right there, can't we? And it's negative. Okay, so now, almost done. I've thrown a lot at you. We're going to make a residual plot. And what we're going to graph, our actual X values. So I'm going to highlight those. I'm going to go Control-C on my PC. I could do Command-C on a Mac. And on a Linux box, I don't remember. I think it's Control-C. And then I'm going to grab these residuals, and I'm going to Control-C that. Now, here's where you got to be careful. I want to put those Y values right next to them, but if I just Control-V it, it's going to give me an error thing. In fact, why don't I do that so you just see it? You see what it's doing? It's just taking that number and subtracting the nothing's there to subtract. So it's messing up. So what we want to do is, I'm going to undo this just so we get a blank screen there. What you do is you go Edit, Paste Special, and just do the values. And what that'll do is that'll just paste all those numbers, not the formula. See what it did? So now we just have numbers. Isn't that nice? So now let's do the residual plot. I'm going to select them all. I'm going to insert a chart. And I want a scatter plot. I don't want that other one. Okay, and those are the residuals. And I don't think I need to edit this too much. I'm just gonna insert it right the way it is. So what am I seeing with this residual plot? Because the last part of this, I mean, how do I know by looking at a residual plot if I've got an appropriate model? Well, what you try to look for is looking for some kind of random scattering. If you start seeing a pattern, then you know it's not a linear model is not a good model. We should be using like a polynomial or an exponential or something like that. Something we aren't going to talk about in this course. But what I'm seeing, aside from this one, I'm seeing it nice. There's a point above, point below, above, below, below. It's a fairly good fit. Remember, that's just the legend I could have got rid of. So what I'm seeing is a nice random pattern for these residuals. So I think a linear model is appropriate. What we're going to do next week is learn about correlation, the correlation coefficient, and that'll be an R squared too, which is just the correlation coefficient squared. And that's another tool we can use. But for this week, this is all we really got to do is be able to make a scatter plot, decide if it's linear or nonlinear, and if it is linear, talk about the direction. We're going to be able to calculate the regression equation, either using, you can go use that Rossman Chance applet to do it, or you can do it on your spreadsheet. We're going to be able to use it for prediction. So remember, you pick an x value, and you substitute it in for your equation. And see, where did I do that? Here, we took an x value, I substituted in my equation and found my y value, and that's my predicted y value. Remember to use the hat over, you remember to use words for your equation, not just x and y. The residual is the actual value minus the predicted. And then we just learned how to do a residual plot. Calculate all those residuals, put the x values next to the residuals and graph that, look for a random pattern. Okay, I'll try to find some examples and post them in the forum about ones that have a pattern so you know a linear model is not good. So this video is long enough. I hope this helps you do it. This is all doable on your graphing calculator too if you have one. If you want to walk through on that, give me a yell. So I'm going to shut this off and upload to YouTube.